Hello everyone. Today our topic is 808 by microprocessor, the data transfer instructions. In this video we are going to cover all the data transfer instruction that is used in 808 by microprocessor. In this series I will cover all the instruction that is used in my 808 by microprocessor, and I will also try to cover some program related to this. So first, what is data transfer instruction? This instruction is used to move data between different locations in the 808 microprocessor. The location involved in this instruction is register, memory, and accumulator. The register in 8085 are B, C, D, E, H, L. The 6 registers are there for the transfer instruction, and there is another built-in register. It is accumulator. Okay, so the first instruction that we will cover, that is move, MOV. So let's just start with the example. If the instruction is MOV B, C, it means B is the destination register and C is the source register. The data, the source register will be copied to the destination register. Here, the data of the C register, that is the source register, will be copied to the destination register, which is B register. Next up, we have MVI. MVI is an immediate data addressing mode. So MVI C, 57H. It means 57H is a 8-bit data which will be stored in C register. Up next, LDA, that is load accumulator. Let's see the example, LDA 2034H. Here 2034H is the memory location in the memory. So this memory location already have a 8-bit data. So after execution of this instruction, the data 2034 memory location will be loaded to accumulator. So if the memory location 2034 has a data of 20H, then after execution of LDA 2034H, accumulator also have the data 20H. Up next, STA. Let's see the example, STA 3050H. So STA is a store accumulator direct instruction where the accumulator content will be stored to 3050H memory location. In the right side, you can see the quick reference picture, that is a MOV, which is the copy instruction, and then the NVI, which is kind of a downloading instruction, and then the LDA, which is the load instruction, and STA, which is the stored instruction. Up next, we have LDAX. Remember, if an instruction have the X letter, it means it indicates the register pair. Let's see through this example, LDAX-B. It means the actual register pair is BC. In the register of 8085, there are general purpose register BC, DE, and HL. To make the pair, we have 3 pairs that are BC and DE and HL. Each register can contain 8-bit data, so a register pair can contain total 16-bit data. So now come to this instruction. The example is LDAX-B. It means it actually represents BC register pair. So through this instruction, we have BC register pair. The BC register pair can contain a 16-bit data, that is the address of a memory. So at that address of the memory, there is a 8-bit data which will be stored in accumulator. Let's just understand with a example. Let's consider B have a 8-bit data 20 and C have a 8-bit data that is 30. So in total BC register pair have 2030 data and memory address is a 16-bit address. So we will find the memory address that is 2030 and in that memory address a data will there. The data will be 8-bit data. So that data will be loaded to accumulator. Please consider at 2030 memory location the data is 50. So after executing this instruction accumulator will contain 50H. Up next we have STAX. This is just opposite of LDAX. So after executing the STAXD, the designated register pair DE having an address of memory, the data of that memory will be stored to accumulator. The opposite instruction of LDAX. Up next we have LXI. Same, we also have a X there. So this is also a register pair instruction. Let's just understand with the example which is LXI H, 1, 2, 3, 4, H. It means the HL register pair will be contain 1, 2, 3, 4. It means H will contain the higher order byte which is 1, 2 and L will contain the lower order byte that is 3, 4. The next instruction is LHLD. The example is LHLD 8040H. After executing this instruction, the data of 8040H memory address will be stored to L register. Copy the content of next memory location into register H. The content of source memory location are not altered. Up next we have SHLD, which is same the opposite instruction of LHLD. Here the content of register L are stored into the memory location specified by the 16-bit address. Here example that is 2470H. And the content of H register will be stored in the next memory location by incrementing the operand. The content of register HL are not altered. This is a 3 bytes instruction as LHLD or SHLD is the operand and this is 1 byte and up next there is 16 byte address. Remember that 8-bit data require 1 byte instruction. So in total there are 3 byte instruction. And the second byte specifies the lower order address and the third byte specifies the higher order address. Up next we have XCHG instruction. This is a 1 byte instruction and the content of the H register is exchanged with the content of D and the content of L are exchanged with the content of E. So this is predefined, then HL will be exchanged with DE. Up next we have SPHL. This is also a 1 byte instruction. Here the SP, it means the step pointer. So after executing this instruction, it loads the content of H and L register into the step pointer register. The content of H provide the higher order address and the content of L provide the lower order address. The content of H and L register are not altered. Up next we have XTHL. This is also a exchange instruction. Here the content of H and L register are exchanged with the content of two memory location pointed by step pointer SP and SP plus 1. Here you have to remember this key point. The register pair are used to trace memory. B, C, D, E, H, L can act as pointer. This instruction only transfer data. They do not form any arithmetic instruction. SHLD and LHLD use consecutive memory location and essential for data handling, program control, and stack operation. The next stack operation is a push instruction. The content of the register pair designated in the operand are copied onto the stack in the following sequence. The stack pointer register is decremented and the content of higher order register V, D, H or A are copied into that location. The stack pointer register is decremented again and the content of lower order register, which is C, E, L or flags, are copied in that location. You can see except push B. That means BC register having the data 1, 2, 3, 4, H and SP before push operation contain 2050H. After push by instruction, SP is decremented by 1. So it means SP having 204FH, and at that location the content of B register, that is 1, 2, is placed. And after that SP is decremented again by 1 and the content of C are copied to that location, it is 204EH. Now SP is pointed to that location 204EH. Up next we have the pop instruction. I will not explain the example, but this is exactly opposite to push operation. You can see in this presentation that how the pop instruction is actually performed. Up next we have in instruction and out instruction. These two instructions are performed when any peripheral is connected to that microprocessor, any timer or counter is connected, and we want to terminate them. For that, we did that in and out operation. Here in the example, in operation in HCH, it means in input we have HCH and the data will be transferred to accumulator, and an out location, the accumulated data will be exported to that output port. Here the key point that you have to remember, that stack grows towards lower memory address. It means stack will have the higher located address, and SP will always point the top of the stack, and in push location higher order first and in pop location lower order first. Input and output in reads data from port to accumulator and out sends the data from accumulator to port. This instruction is essential for data handling, subroutine operation and IO communication. Thank you so much for watching and supporting our content. Your like, comment and encouragement motivate us to create more educational video. If you find this lecture helpful, don't forget to like, share and subscribe to our channel. Happy learning. See you in our next video.